Suppose a police officer is 1/2 miles south of an intersection, driving north towards the intersection at 40 miles per hour. At the same time, another car is 1/2 mile east of the intersection, driving east away from the intersection at an unknown speed. The officer's radar gun indicates 20 miles per hour when pointed at the other car. That is, the straight line distance between the officer and the other car is increasing at a rate of 20 miles per hour. What is the speed of the other car? Okay, so let's represent the distance between the officer's car and the intersection by x here. Let's represent the distance from the driver to the intersection with y. And let's represent with z the distance between the officer's car and the driver's car. Okay, z here. Now, at any moment, the following should be true. X squared plus y squared equal z squared, right? Now that is true because the officer's car, the driver's car, and the intersection, they form at any time a right triangle, right? Okay, so now, taking derivatives of both sides of the equation, we're gonna get the following. Remember, the derivative we take is respect to time, right? So derivative of x squared with respect to time is twice x dx dt, right? Because remember, we're not taking the derivative with respect to x, we're taking the derivative with respect to time, so we have to attach this dx dt, right? Now, if we continue distributing our derivative, here we're gonna have the derivative of y squared, 2y dy dt, right? Dy dt. Remember, we are not taking derivative with respect to y, we're taking derivatives with respect to t. So we have to attach this dy dt. Similarly here, the derivative of z squared with respect to time should be just 2z derivative of z with respect to time, right? So here I have the relationship between the rates of change. Okay, so now let's substitute what we have and let's find what we don't have. Right? We have x. They say that x is just equal to 1/2, right? So 1/2 here. Dx dt is the speed of the officer's car, right? Notice x throughout time is decreasing, right? Decreasing over time, better said, right? Decreasing over time. So according to this information, that is 40 miles per hour. But since x is decreasing over time, right? This should be minus 40 miles per hour, right? Don't worry about the units, they're all compatible. So let's just do the substitution numerically, right? Twice y. What is y? They say y is also 1/2 a mile, right? So a mile here. dy dt is precisely what they are asking you to find out, right? So let's just write dy dt here, equal twice z. Z I don't have, but I can find the value of z, since notice for x equal 1/2 and y equal 1/2, x squared plus y squared is equal to z squared, right? So this means that 1/2 squared plus 1/2 squared equals z squared. And from there, I can have that z is just the square root of these two guys added, right? 0.5 squared plus 0.5 squared. Well, what is that approximately? Let's compute it. A square root, where is square root is here of 0.5 squared plus 0.5 squared is approximately equal to 0.707, right? 0.707. 707. Okay. Rounded to 3 decimal places for accuracy, right? So that is what we're gonna place right here, 0.07, okay? And that has to be multiplied by the derivative of z with respect to time, which is something that we have also, right, given. So let's write here 0.707 times the rate of change of z over time is just 20 miles per hour, right? 20 here. Great. Now, you're supposed to solve for this guy, right? Now, in general, you may have numbers that are not easy to compute, right? Here you can say, okay, professor, 2 times 1/2 is just 1. This disappears here the same, right? Minus 40 left. But what if this is 3? It will not disappear, right? Or this is 5. We don't know, right? So I'm going to show you how, in the most general case, you can get your dy dt using your calculator, okay? So using the calculator, first, we're going to compute this. Notice this term will go to the right with opposite sign, and in the end, we have to divide by this multiplication, right? So let's do it together. So 2 times 0.707 times 20. Notice how I'm writing this number within parentheses, so I don't have to write the multiplication symbol, right? This is this guy, right? Now, this, as I said, right, goes to the other side subtracting, right? Because that's the sign of all these changes, right? Subtracting, so minus 2 times 1/2. Again, right now, the numbers are friendly, but in your homework, in your assignments, they may not be friendly, right? So I'm showing you worst case scenario, what you should do, right? This whole thing, subtracting, right? And the whole thing divided by this, right? You say, professor, but that's just 1. Yeah, I know. But what if it's not, right? So you will have to do this 2 times, right? This is it. This, guys, is going to give you the answer to this. 68.28, right? With a fairly good level of accuracy, 68.28, okay? So let's write it out, 68.28. And in the end, you may attach the units, miles per hour, right? You don't have to carry them along the process. That's it. This answers the first question, right? Now, they say, now suppose that the officer's radar gun indicates negative 20 miles per hour instead. That is, the straight line distance is decreasing at a rate of 20 miles per hour. What is the speed of the other car this time? All right, so the idea is the same, right? precisely the same. The only thing that is going to change will be this. This guy here on the left, dz dt, will change its value to negative 20, right? Negative 20. That's all. Now, following the same idea as before, right? We're going to do the computation. We're going to isolate dy dt, right? Computing this first, right? Computing that first, which is going to be 2 times 0.707, right? I'm using the Desmos scientific calculator. It's OER, free for you to use, guys. Strongly recommend you to use it. Or if you prefer to use your scientific calculator, it's also okay, right? But the idea is that, again, we're trying to get this computation done independent of how easy or difficult the numbers involved are, right? So no matter what numbers you get, this should be computed first. So you subtract this part, right? And then you divide by whatever you have here. In this case, this divisor is just 1, we all know that. But in case it's not, you have to write it this way, right? Parentheses must be used. They matter so that the computation will be okay. We get 11.72 now, right? With a great level of accuracy. So 11.72 miles per hour should be the answer for the second part, right?